Hello all, here I am ready to do the 2014 GL2 cross section. Just make sure I've got all the equipment that's needed. I've got the resource sheet, I've got the cross section itself, a piece of paper ready to draw on the notes, a protractor, ruler, pencil and eraser. So just like we've done in class, but in an environment that you can rewind it and play it again and slow it down and pause it, I'm going to show you how to construct the cross section. So the first thing I like to do with the cross section is try and start with the youngest rocks. So obviously we've got to use our line XY here, so we're going to just make some marks on there to show the extent of the cross section that we're going to draw. And the first thing I'm going to notice is that we've got some horizontal bedding here. We've got this cross, which means horizontal bedding, so I'm going to plot that on first because that is most likely going to be some of the youngest stuff. So I'm going to put that on there like that. Looking around the rest of the cross section, we can move that out of the way a minute just to see what's going on here. I noticed that the outcrop pattern for this particular rock unit is quite similar to these diamonds here. So these spots here quite similar to the diamonds, and we can see that it's dipping at 10 degrees, which is completely different to the rocks that are below, which are dipping steeply here on the west side and less steep or quite gentle on the east side. The other thing to consider with this particular map is we've got an igneous intrusion over here. We can tell that from the metamorphic aureole that moves around. Now that means that that's going to probably cut across, well, it's certainly going to cut across all of these rock units here. It's younger than the fault, it's younger than all of these rock units at the bottom, but it is older than this horizontal bedding that's on top. And the last thing that is obviously quite young is this dike, as this cuts through the fault and it cuts through the steeply dipping beds, and it doesn't cut through there. So what I'm going to do is I'm going to mark those things on first, because if they're going to cut across a lot of the other rock units, it's best to draw those on first. So I'm going to put those spots on there. I'm going to put this dike on here. And now we can see that we're going to run into a problem with putting on the intrusion. So what I'm going to do with the intrusion, I'm actually going to sort of sketch in on the map. I'm going to connect up what would be the intrusion underneath that rock unit with the diamonds. So I can then plot it onto my piece of paper, but knowing that that is going to be underneath. We can also do the same with the metamorphic aureole to make sure that we get that in the right place also. So we know that that's going to be the Pluton and that's going to be the metamorphic aureole. So we can now start to transfer some of this information onto our sheet here. So the first things I'm going to put on are those horizontal beds. Now, the reason that I have decided to do this on a piece of paper printed off from the PDF document that's available on Moodle is to show you what to do to help you practice when, as you can see here very clearly, the cross section on the resource sheet is bigger than the cross section on the actual piece of paper. Now in the real exam, in the GL2 exam, this won't be the case. They will match perfectly. But it is important to be able to train using these differences in scale. So all I'm going to do is I'm going to sort of allow equal each side. The one thing that is important is to notice that there is a fault here. So if you come across that issue, the best thing to do is line it up. Put your fault on, because that is the bit that's already marked on the map. Fault 2. And then we can make sure that fault 2 is at least in the right position. So everything else will tie in correctly with fault 2, or close as near as it can. So I'm going to move that up, keeping fault 2 fairly in line, so that I can now show where my horizontal bedding is. So that's going to be the horizontal bedding there, that's going to be the triangles. And where my horizontal bedding is on this side, triangles. This one we identified was going to be dipping at 10 degrees to the west. So, oh, I can put the dike on as well. Put that dike on there. So at this point we can start drawing these in. Now, if it was absolutely perfect, those horizontal beds may well line up, and they almost do, but obviously we're dealing with some slight scale issues, so we're going to put that on, and we're going to put that on, and I'm even going to connect those up because they are the same rock unit, it is the same unconformity, it's cross-cutting relationship. There we go. Just make sure we understand that that's the triangles. So I know that this one is dipping at 10 degrees, so we'll get the protractor in here. Make sure that that line is horizontal, so it will actually be horizontal the same as the unconformity. So we measure that up, and then we're going to plot in our 10 degrees to the west towards X. And then we can draw that with a solid line where it's proven, and with a dashed line where it comes above the ground. We can now put the dike on, and you can see that we are going to have a bit of difficulty here with the matching up of the dike and the bed. So what I'm going to do is, to make this work for me in this particular scenario, I'm going to move that across just a little bit, but that's okay. Because in geology we have to deal with little setbacks like that. Just check the stippling on the dike, so it looks right. And now I can go back and focus on the Pluton, which comes out underneath this unconformity, which is here, and it's metamorphic aureole there. With the Pluton, we're just going to apply a gentle sort of angle to it, so it's going to be quite steeply dipping, but we're not going to do it vertical. We're going to just bring it out just a little bit, and we're going to show it going under there like that. We can be quite happy and strong with that line because we know that that is going to be younger than the rocks around it. And we can also put in our metamorphic aureole, which will cross the other rocks anyway and metamorphose them. And just for clarity, we can show that that is rock unit B, and that the dike is rock unit A, and we can even put the triangles in as being rock unit G. And if we need to, we can just bring that above to show that that is G. And we've got this one as well, the dots, which is rock unit H. So we've got the major features now plotted on. It's now time to turn our attention to what's going on underneath. So we've got displacement from the fault, and we've got these steeply dipping and shallowly dipping beds. And the first thing that I think is important to do is to start having a look at this and thinking, well, if we've got steeply dipping beds on the west side and shallow dipping beds on the east side, and a good example of where the two are together is over here, what this means is that we've got an asymmetric fold structure. And if the dip arrows are pointing away from each other, it's going to be an anticline. So we can see here that this is the axial planar trace of this particular anticline. And we've got repeated beds, so we know that that's the anticline. This bed isn't repeated because obviously it's underneath all of this stuff, and it's actually been taken over by the intrusion, so that will go there. And we've got a fault here which has changed the whole layout. But if we look again at our repeated beds, we can see that's dipping away that side, that's dipping away that side. That's the same scenario as here, which is the dots, plane, dots, dots, plane, dots. Therefore, this must be another axial planar trace. So, with all of that in mind, we can now draw carefully these dipping beds. So we can draw in this bed here, and because, and this is rock unit C, because we've just identified that, it's worth having a look at where that will outcrop. So exactly the same skill that we used over here to extend that line through, so we know where those dots are going to outcrop, which is going to be there. So that's going to be plane, that's rock unit E, but this is going to be the dots, this is going to be another part of rock unit C. At this stage, I do like to put on the arrow so I can remember what I'm doing. So that's 70 degrees to the west, and then we know that this one is going to be 30 degrees to the east. We've got the fault already marked, so that's fine, so we can bring back in rock unit C there. We've got brand new rock unit D here, shaded, and rock unit C, and rock unit E, and rock unit C again. Put our dip arrows in, 30 degrees to the east, 70 degrees to the west. And we can have a look for some more dip arrows. We've got a dip arrow here, which is going to be, now watch this very carefully, this is on this side. So I'm going to plot that exactly where it shows 30 degrees there. Because as I lift this off, I'm going to have a look and see if I can work out. I saw that there was an anticline there. I saw that there was an anticline there. There's got to be some sort of syncline in the middle. And if we look at repeated beds, we've got dots, so of the C bed, shading of the D bed, dots of the C bed. I am going to suggest that there is a synform or synclinal axial planar trace in there. So now we can build this together. I'm going to go back to our fault, so I've got everything in the right place, accepting that some of it is going to be slightly out of touch, but we can't do anything about that until the actual exam where we get all the nice correctly drawn papers. So we've got that line there and that line there, and that's the E bed, and that's going to be dipping 70 there, and this is going to be dipping, we've got a dip here of 30, this is either side of the dike, so we know that that line there is dipping. But remember, we've already ascertained that the anticline is going to be in the E bed, so we know that this is also going to dip that way. So that's all going to be 30 degrees to that side. So let's start by just doing that section so we don't get confused. So we can move this out the way, bring in our protractor, and like I always suggest, we're going to draw some small lines to begin with. So we've got 70 degrees on this side, on the west side. I'm fairly confident that nothing else over this side is going to happen, but I'm still only going to draw that in. I'm only going to commit to a small portion of that line. We've got a join here, which we said the anticline was in the middle there, so we're going to do a 30 degree here. But again, I'm only going to draw the start of it. Actually, we can be fairly happy that that is going to join up with the C bed there. That actually makes a lot of sense. So we can put in our final 30 degree C, the top of the C bed here, which ends at the fault, and it would appear now that the C bed is older than the D. So the D is there, C is below. We can put some dots on here. And if we want to, we can neaten this up by removing those arrows and numbers. But if we put them in quite light pencil, then it won't matter anyway. And we've got this bed here, which is the dotted bed. Just double check that doesn't actually come. No, that ends there. So I'm quite happy that we don't need to put that on. So I'm gonna finish that off down there. And so that is the dotted. That's the C bed again. And again, we can remove that if we need to. And in the middle we have the E bed. So again, we can remove those. And we can put that in there, E, which is coloured in white. So we'll just leave that as it is. Excellent. So we've got this side really starting to form. Let's now do the other side of the fault. So we've suggested that we've got 30 degrees here and we've got 1730 there. So just a check of being happy with the folding. So we've got a syn form coming first and then an anti-form afterwards. Got the C bed there, and that's going to be 30 degrees that way. We've got the D, C boundary, E, and that's 70 that way. And if we move that up again, 30 that way. And we'll just stop there because there's obviously something going on here. We've got the metamorphic oriel there. We've got another bed to get in here, which is going to be just a slither of C. But we'll leave that for the time being. Let's get this syncline in first. 30 degrees, and I am happy that that's going to be 30 degrees that way. I'm not going to push this line very far at all. Just want to give the hint of what's going on, and just to check with the map what's going on here. So we've got D on this side of the fault, we've got C on the other side of the fault, so I'm going to put that in quickly to remind me of what's going on. And then the one after C is going to be D bed again, so we put that in. Now, because we've identified that our axial planar trace is going to be here, and we've identified that our synformal axial planar trace is going to be here, that means that this is going to have to come down from this point 70 degrees and will actually form the syncline here. And now you can start to see the reason for not extending the lines too far before you realise what's going on. Okay, and that's obviously D on that side as well. That whole bed is the D bed. So now we can bring in, we've got another anticline going on here, so we can bring in another 70 degree to the west. And I'm aware that that is going to curve round here. Obviously the axial planar trace will be through the centre there. So what we can actually do from this point is we can measure the thickness of the C bed. We should be happy that we've got a thickness here that we've plotted and a thickness here that we've now plotted. So I'm just going to take a measurement of how thick that C bed is, and that's measuring, again, you can be very precise on the actual exam, but it's difficult with how we've got things set up here, but we say 14 millimetres. So I'm going to go for the same here, 14 millimetres to that point there. And I now need to recreate the same angle as above. So that needs to be, that line needs to be at 30 degrees. So I'm going to keep that held there. And then we can, obviously I'm not going to draw it down to here because I know that it's got to connect up with this line here to form the bed. There we go. So we've now got our C bed all the way around. And it's now time to finish off all the bits that we're missing, get all the final bits sorted. So there's a little bit of detail that needs to be added onto here, but because it's getting a bit fussy on here, and it's getting a bit fussy on here, there's quite a lot going on. I'm going to go back to the map and just double check that I'm happy with what's going to happen here next. I've got a C bed that I need to draw dropping down, and so I'm going to make sure that I get that in the right place. Obviously it doesn't end there. We know that the C bed actually ends there, so it's this one that's important. It's this edge which is going to be at 30 degrees. So again, our fault back on there. It's going to be that point there that's important. Take those out. Don't need to show those anymore. And that is going to come straight into the intrusion. And that's going to be C bed there. So we've just got the final elements to do now, the axial planar traces, movement on the fault and extension above ground level. I've just put these letter E's in here to make sure that the examiner knows that I understand what is below the C bed, and then there's the D bed there, so we've got that in. We've just got to extend things above ground. As the dike cuts through everything here apart from that spotted bed, apart from bed H, I'm going to extend the dike up using dashed lines up to bed H. I'm not going to go through it. The fault is tricky one. We can't see whether the fault actually cuts across these beds on the outside, so we're just going to extend that up to there. Those beds are very young, so we'll just leave that there. And then we need to extend the dipping beds, these dipping beds here. So extend those up to that point, that one up to that point. We can't really do much here, but we can extend this across here. It's not going to cut through the dike, obviously. And can't really get much in there, but that's okay. So we need the movement on the fault. So say the bed C has come down, so the hanging wall has been down thrown. It's a normal fault. And the axial planar traces. We have one here, which is going to be a syncline. And we have one here, which is going to be an anticline. And we have one here, which is also going to be an anticline. And there you have it, the full and correct version and how to produce the cross-section for the 2014 GL2 map.